UNIX, the textbook, 3rd edition. Overview of operating systems. Objectives. To explain what an operating system is, to describe briefly operating system services, to describe character and graphical user interfaces, to discuss different types of operating systems, to describe briefly the UNIX operating system, to give an overview of the structure of a contemporary system, to describe briefly the structure of the UNIX operating system, to detail some important system setups, to describe briefly the history of the UNIX operating system, to provide an overview of the different types of UNIX systems. 1.1 Introduction. Many operating systems are available today. Some general enough to run on any type of computer, from a personal computer, or PC, to a mainframe, and some specifically designed to run on a particular type of computer system, including real-time computer systems used to control the movement of mechanical devices such as robots, tablet computers, and cell phones. In this chapter, we describe the purpose of an operating system and the different classes of operating systems. Before describing different types of operating systems and where UNIX fits in this categorization, we present a layered diagram of a contemporary computer system and discuss the basic purpose of an operating system. We then describe different types of operating systems and the parameters used to classify them. Then, we identify the class that UNIX belongs to and briefly discuss the different members of the UNIX family. The people who use UNIX comprise application developers, systems analysts, programmers, administrators, business managers, academicians, and people who just wish to read their email. From its earliest inception in 1969 as a laboratory research tool, it was further developed in the academic community, and then endorsed for commercial uses. In its Vir Scion today, UNIX has an underlying functionality that is complex but easy to learn, and extensible yet easily customized to suit a user's style of computing. One key to understanding its longevity and its heterogeneous appeal is to study the history of its evolution. 1.2 What is an operating system? A computer system consists of various hardware and software resources, as shown in a layered fashion in Figure 1.1. The primary purpose of an operating system is to facilitate easy, efficient, fair, orderly, and secure use of these resources. It allows the users to employ application software, spreadsheets, word processors, web browsers, email software, and other programs. Programmers use language libraries, system calls, and program generation tools, e.g., text editors, compilers, and version control systems, to develop software. Fairness is obviously not an issue if only one user at a time is allowed to use the computer system, including single-user desktop systems, laptops, tablet computers, and cell phones. However, if multiple users are allowed to use the computer system, fairness and security are two main issues to be tackled by the operating system designers. However, if multiple users are allowed to use the computer system, fairness and security are two main issues to be tackled by the operating system designers. Hardware resources include keyboards, touchpads, display screens may also be touchscreens, main memory, commonly known as random access memory or RAM, disk drives, network interface cards, NICs, and central processing units, CPUs. Software resources include applications such as word processors, spreadsheets, games, graphing tools, picture and video processing tools, and internet-related tools such as web browsers. These applications, which reside at the topmost layer in the diagram, form the Application User Interface, AUI. The AUI is glued to the operating system kernel via the language libraries and the system call interface. In the top-down view, which we espouse in this textbook, an operating system can be viewed as a piece of software that isolates you from the complications of hardware resources. You therefore do not have to deal with the extremely difficult, and sometimes impossible for most users, task of interacting with these resources. For example, as a user of a computer system, you don't have to write the code that allows you to save your work as a file on a hard disk, use a mouse as a point-and-click device, use a touch screen or touchpad, or print on a particular printer. Also, you do not have to write new software for a new device, e.g., mouse, disk drive, or DVD, that you buy and install in your system. The operating system performs the task of dealing with complicated hardware resources and gives you a comprehensive machine with a simple, ready-to-use interface. This machine allows you to use simple commands to retrieve and save files on a disk, print files on a printer, and play movies from a DVD. In a sense, the operating system provides a virtual machine that is much easier to deal with than the physical machine. You can, for example, use a command such as cp memo letter to copy the memo file to the letter file on the hard disk in your computer without having to worry about the location of the memo and letter files on the disk. The structure and size of the disk, the brand of the disk drive, and the number or name of the various drives, floppy, CD-ROM, and one or more hard drives, on your system. 1.3 Operating System Services. An operating system provides many ready-made services for users. Most of these services are designed to allow you to execute your software, both application programs and program development tools, efficiently and securely. Some services are designed for housekeeping tasks, such as keeping track of the amount of time that you have used the system. The major operating system services therefore provide mechanisms for following secure and efficient operations and processes. Execution of a program input and output operations performed by programs, communication between processes, error detection and reporting, manipulation of all types of files, management of users and security. A detailed discussion of these services is outside the scope of this textbook, but we discuss them briefly when they are relevant to the topic being presented. 1.4 Character, command line, versus graphical user interfaces. In order to use a computer system, you have to give commands to its operating system. An input device, such as a keyboard, is used to issue a command. If you use the keyboard to issue commands to the operating system has a character user interface, CUI, commonly known as the command line interface. If the primary input device for issuing commands to the operating system is a point-and-click device, such as a mouse, a touch screen, or a touchpad, the operating system has a graphical user interface, GUI. Most, if not all, operating systems have both character and graphical user interfaces, and you can use either. Some have a command line as their primary interface but allow you to run software that provides a GUI. Operating systems such as DOS and UNIX have CUIs, whereas Mac OS, OS/2, and Microsoft Windows primarily offer GUIs but have the capability to allow a user to enter a DOS or Unix-like terminal screen. Although Unix comes with a CUI as its basic interface, it can run software based on the X Windows system, Project Athena, MIT, that provides a GUI interface. Moreover, most Unix systems now have a state-of-the-art X-based GUI. Mac OS X, Darwin, running on Apple products, is the most well-known GUI-based Unix system. We discuss the Unix GUI in Chapter 23. Although a GUI makes a computer easier to use, it gives you an automated setup with reduced flexibility. A GUI also presents an extra layer of software between you and the task that you want to perform on the computer, thereby making the task slower. In contrast, a GUI gives you ultimate control of your computer system and allows you to run application programs any way you want. A GUI is also more efficient because a minimal layer of software is needed between you and your task on the computer, thereby enabling you to complete the task faster. It is also malleable and gives the user more control. Because many people are accustomed to the graphical interfaces of popular gizmos and applications such as Nintendo and web browsers, the character interface presents an unfamiliar and sometimes difficult style of communicating commands to the computer system. However, computer science students are usually able to meet this challenge after a few hands-on sessions.